I'm Ralph Ferguson, Managing Director of the Texas Tech University Ethics Center. And this morning I am visiting with...
I'm Alice Young. I'm the Associate Vice President for Research, and my work at Tech focuses on ideas of responsible research and research integrity.
How would you describe the Texas Tech University safety effort?
I think the safety work at Texas Tech probably took off with an unfortunate incident in 2010 when a graduate student was injured. The U.S. Chemical Safety and Hazard Investigation Board decided that Texas Tech was going to be investigated because the chemists and others who work on the U.S. Chemical Safety Board, as it's called, were concerned that there were too many accidents occurring in university laboratories.
Wow.
And the incident at Texas Tech was the first large incident following a death at UCLA. And CSB decided that the Texas Tech incident needed to be investigated.
Can you clarify CSB?
U.S. Chemical Safety and Hazard Investigation Board. There's a report that the CSB made about their investigation that has a very good video.
Okay.
Talks about safety or accidents or incidents that have injured people on university campuses. And they pointed out that university researchers, faculty, staff, and students may need to work with hazardous materials.
Yep.
And that the people working with those materials may not understand the risks involved.
Okay.
And they may find themselves in a dangerous situation.
When a scientist decides to work with a chemical or some type of toxin, where do they get the instructions to say this is the way it should be managed?
There are safety data sheets. Those are information that lists what's known about that chemical. The university at Texas Tech, we have electronic and or paper versions of that. Any laboratory that has chemicals in it is asked, the chief of that laboratory, who's usually a faculty member, is asked to maintain a link to the material, the SDSs, so that as I'm getting ready to use that chemical, I can learn what the characteristics of that chemical are. These are safety data sheets that are developed, I think, by a consortium of industry and academic and government experts to explain what do we know about how a particular chemical needs to be handled.
Most labs, you have inexperienced freshmen, sophomores come in, then you have the experienced, more mature graduate students come in. Mm-hmm. How do we protect ourselves from error in judgment of the less mature?
And it may not always be an error in judgment. It may be I haven't yet been exposed to that information. I may not know there's a problem. We have expectations about how chemicals are labeled. We also have expectations of that if you're going to go into certain areas, you need to have the kind of training to go into that area.
Okay.
And you need to be wearing the right kind of personal protective equipment.
Right.
Very often, in an undergraduate teaching laboratory, the faculty have worked to design work that can be done with materials that are less hazardous. As you make a decision, you're going to take a more advanced class, you're probably going to be asked to take more advanced safety training. As we were learning from the Chemical Safety Board and that 2010 incident, one of the things we did was interview students about what kind of training have you had for safety. And one of the things we heard from many students is that the safety videos were old-fashioned and outdated. The information about the chemicals, or sometimes it's biological stuff, that was correct, but the way it was presented was left a lot too desirable. Cornell has a video that they put out last year. Apparently a student was carrying a bottle and he didn't have it in the right kind of protective gear. And he hit something and it spilled. He wasn't injured. It was not the chemical didn't hurt him or anybody around him. But Cornell because they wanted other people to think about what might happen if something comes down that hall that I don't expect, that runs into my bottle.
Okay.
And the students have made a great video showing all the ways something can go wrong.
Would it be prudent maybe for a university or even for the federal government or our state government to use avatars to make these types of safety films?
One of the things I like about the CSB film is that they have some excellent animations. Some of the best avatars that I've seen are demonstrations of why you want to wear certain kinds of PPE, which is personal protective equipment.
Okay.
Why do I have to wear this set of goggles? Why do I need this face shield? And animations are a great way to show
To display that.
if something unexpected happens, you want to have this kind of face shield because things do splatter all over.
Right.
And if you only have this much on,
Of when individual scientists, professors in particular, may ignore safe best practices, what happens there?
one of the offices that the university has is an Office of Environmental Health and Safety. And the staff in environmental health and safety include a number of people who have training. Their education was in areas like chemistry, microbiology, physics, engineering. They are surveyors. They go into teaching laboratories and research laboratories, art studios, and research sites to see what kind of hazards may be there, what steps has the department or the individual taken to minimize the risk associated with those hazards.
Okay.
If there is a situation in which a faculty member perhaps allows a student to do something unsafe, the university can close a laboratory or restrict access or ask for retraining. Probably the most important thing we're doing now, Texas Tech is asking all faculty who run studios or research sites or laboratories to develop a safety plan for their work area. The faculty are the experts. They're the ones who know why you want to work with certain hazards. They know why you might need to use certain materials in creative work, and they know the potential of that material, both to make something beautiful, but also are there any dangers associated with using it? And we've asked faculty to identify what do you need to do to work safely.
When an institution or an individual do not abide by the safety protocols, is there an outcome that could hurt funding for the institution?
The discussion actually led to the formation of a National Academies Committee to look at safety in academic labs. And that committee has just issued its report. It's a book called Safe Science.
Okay.
It's available online. It has a whole group of recommendations for what should university leaders be doing, what kind of actions are helpful to increasing safety in university laboratories. One of the things that we talk about in the report is what kind of consequences should federal agencies consider the safety record of a university in funding decisions.
Good point.
Investors think about the safety record of a company when they decide to invest.
That's correct.
Another point that the report looks at is how should we set up opportunities for faculty to talk about their safety work and students to talk about their safety work in the normal academic life? Would it be a good idea for a student who is planning a master's thesis or an undergraduate thesis or a doctoral dissertation to think about safety during the planning process, during the proposal process? Think about how they achieve their safety goals as they're writing the document.
Where does policy at the administrative level write the guidelines or the disciplinary protocols that faculty have to take and form? And then how does policy get to the point of saying, okay, this faculty member has done the right thing?
That is one of the university's operating policies. And in fact, we ask all faculty and administrators to and students to be aware of it. This is the CHP that we ask everyone at Texas Tech to be aware of that chemical hygiene plan. Chemical hygiene plan is based on recommendations such as the OSHA recommendations,
Okay.
Recommendations that may come from, say, experts in fire safety, experts in electrical, mechanical, height safety, working with complex electrical equipment or complex biological equipment. What kind of guidance do we have from national policy?
Uh-huh.
Where do you find the references? Where do you find the resources for that? Who are your local people at the university that can help you think through what kind of cabinet do I need to house this material?
When a chemical hygiene plan is made, something that you point out earlier, these things have to be revisited. So how does the policymakers at our institution revisit this with our research scientists?
We have a faculty committee, the Institutional Laboratory Safety Committee, that works with Environmental Health and Safety Division, and they have worked on revising the chemical hygiene plan. We try to revise it at least annually to look at, are there new fire standards? Are there a new understanding of the risk associated with a particular biological agent? And probably the best idea we've had is they have students on those committees. It helps a student who might be interested in a career as a chemist or career moving into some areas of engineering. Think about, there may be career opportunities related to safety engineer, biological safety officer, are two that come immediately to mind. But it also helps the students understand not only how do we do something so it's safe for you and me as individuals, but how do we do things that are safe for the environment? How do we do things that are safe for the physical structure of the institution? Because all of that is involved in university safety planning and the chemical hygiene plan.
When we look across disciplines at Texas Tech University, do you think that what we're doing, our strategy looking ahead, is going to be very effective for us, and how is it going to be effective for us?
I think it's important to be public about potential mistakes we've made in the laboratories. It's important not to be punitive the first time there's a near miss, because we need to learn from it. We need to say, okay, what almost went wrong there? Why did something almost happen? And to do that, as a faculty member running a laboratory, I have to have good conversations with my students so that they can bring me a problem. When a problem happens, we need to be able to bring it to the next person and ask for help. We have to be able to talk about where mistakes happen. And I think that's probably the most important part of having a good safety culture, because it gives you the freedom to assess, yes, to make a decision. I have to work with this hazard to do the kind of research I want to do, or teaching, but I need to learn how to work with it appropriately. And as a student, I need to be able to talk to my professor.
Right.
As a professor, I need to be able to go ask my chair for resources without getting punished. And I need to be able to go ask environmental health and safety for guidance. In some cases, I may need to contact somebody at another institution who knows more, or in an industry that's already using an advanced material or a nanoparticle or something else that we're starting.
Dr. Young, thank you for coming in.